All right. I guess I look back today, and I think it's my 8th year of doing this. And some of this stuff seems awfully mundane to me all the time, but I think many of you, this will be your first time. Today I'm kind of going to incorporate kind of a lesson plan into what we have going on here. This year's theme is energy now and forever. Electrolyte? Sure. Electro conducts electricity. All right.
That's cool.
So now it's attracted to my little PVC pipe, and as a result, I have really controlled my bubble. I can take my bubble for a walk. Go to the park. All right, so I'm going to use this big heat source to light this. And now we've got flame. Now, normally we'd think, okay, what's going to happen when we put it in the water? Look at it, like I said, look at the bubbles, look at the top.
The water is on fire.
Carbon dioxide has some very interesting characteristics itself. One of the things that it does is it's very soluble in water, which means when you put it in water, it'll become part of it. And we kind of like that because when we drink a pop, we sure like that pop to have what we call fizz, right? And that fizz is really carbon dioxide. All right? Well, what I have here is I've got a beaker of water, or excuse me, a flask of water, and I put a color indicator in it. And what I did is I changed the pH. So I made this what we call a base solution. Carbon dioxide takes water and it actually makes it acidic. And we can test that idea by using a very good carbon dioxide source, such as dry ice. Here I have some chunks of dry ice. Dry ice is solid carbon dioxide that's frozen. And it actually, you know what, there's an interesting story behind this. Notice that when I hold it, you don't see it dripping down like you would an ice cube, right? That's because carbon dioxide goes through a process called sublimation. It actually goes from a solid straight to a gas. So you can see the gas coming right off of it. If you look down, you see the smoke coming out the bottom. All right? So now when I add this to my solution, not only is the carbon dioxide dissolving, but it's actually changing some of the chemical makeup of this solution. Okay? We are now going from a base type of solution to an acidic. And I believe we just hit green or blue, right? Now, to some extent, that's kind of a good thing, because when we are going through the problems that we're going through now with the carbon dioxide in our atmosphere, it's kind of reassuring to know that a lot of it will dissolve in the water that's around our planet, all right? But there's still a problem with how are we handling the carbon dioxide now. simple test that we do for the presence of oxygen is exactly how it handles combustion or burning. When I blow this out and it's glowing red and I put it in the presence of a large amount of oxygen, it just simply relights. And this is actually a little laboratory test that a chemist would do to test for the presence of oxygen. You take a red glowing wood splint, you put it in the presence of oxygen, it lights, ding, 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 you've got oxygen. Cold environment. And for that, I'm going to use liquid nitrogen. What have I got in here? I've got some squished balloons. See, what the liquid nitrogen does is it actually creates such a cold environment, the molecules want to get closer together. Maybe you can think closer together to stay warm. I don't know. But as a result, the gas that was in much, much smaller. Now, they might make a pop because they've been sitting in there for a while, but don't be too alarmed by it. There it goes. It's going to break apart that hydrogen peroxide again to produce that oxygen. So I'm going to dump some water in there. Enough is good. More is always better. All right. And can't look like toothpaste without bubbles. And then the peroxide.
It's smoking.
Okay. More try. I don't believe I hit it. I think I got the oxygen. I have no idea. See, normally the oxygen's a nice blue color. And I can see from here this is not a very nice blue color. And it's not supporting combustion a whole lot. Yeah, a little bit. Again, this is just your typical wood splint that we had burning in the presence of a great deal of oxygen. And some other contaminant, which I'm not sure.
Did you know? It's a bottom.
Methanol is one of the more flammable types of alcohol. They often call it wood alcohol. And it was usually, the reason why they call it wood alcohol, I believe, went back to the days of moonshining when they made their batches incorrect and would get the wood alcohol and they said it would make them go blind. All right, so now we've got our oxygen inside of there. We've got our methanol, so now we should have combustion. Okay, and this is called a whoosh bottle. It will make a loud whoosh, but it will not make a loud pop.
Whoosh.
The reaction's taking place. It's going to be a bright flame, a little pop.
Big pop.
All right.
Do it. Do it.
All right, everybody ready? We're going to count of three. Ready? 1, 2, 3. And maybe simulate that this is your basement. And this could be the pilot light on your water heater, okay? And this would be your solvent or your paint thinner stored in a garage, maybe in a very unsafe area, right? And again, it doesn't take a liquid to create the fire. Notice all of these that have combusted have pretty much been in the gas state. So hexane is heavy enough where I can pour it right on down the ramp and it's invisible until it gets to the flame. Where the combustion takes place and it burns right back up again. And this one has nothing to do with combustion. It's just purely for entertainment. what I'm going to do is I'm going to make 2 compounds in a row from these clear solutions, and both those compounds won't dissolve in waters, and they also have some interesting colors. So let's take a look and see what they're going to tell us. There you go. Happy Halloween. All right. Hey, I want to thank you guys all for coming tonight. I really enjoy doing this every year. Every year I keep looking at myself going, this is a lot of work. And you know, I keep seeing more and more people out here, and I really think it's important, you know, to experience some of this stuff. I think, you know, through the media, I think chemicals in general right now are getting kind of a bad rap. But like I've always told my students, you know, it's always moderation, moderation, moderation. And you know, getting exposed to some of this might someday inspire one of these little guys to take it up and do some great things for this country that are going to be positive. All right. So I appreciate you for coming out. Thank you. That we can do with the static electricity is play with bubbles. All right. And tonight I have some Gateway to Science bubbles that you can find at the front desk for a nominal fee. The finest bubbles in town.